Okay, so this is our first little mini lesson on our end-of-year review standards. This first standard comes from your workbook. It is 7.NS.1. And generally, this standard is about adding opposites. And every time we add opposites, they equal 0. We're going to look at a few different problems, but we're going to skip through and just cover very few out of your workbook. We're going to look at problem 3. It says that at 11 p.m. it was 48 degrees. The temperature was 6 degrees cooler by 7 a.m. By 11 a.m., the temperature was 48 degrees again. What integer represents the number of degrees the temperature changed from 7 a.m. to 11 a.m.? So it started at 48 degrees and then it got 6 degrees cooler, so it dropped 6 degrees. What must have it added in order to equal 0, as in there was no change in the temperature? It started at 48 degrees and it was 48 degrees again. It had to have increased 6 degrees. So 6 degrees was the temperature change. Number 13, what number do you need to add to negative 33.4 to get 0? So you're going to take some number and add negative 33.4 and it equals 0. We know we can add opposites to equal 0, so the opposite of negative 33.4 would be positive 33.4. Standard 7.NS.1b. These standards deal with distance on a number line. Sometimes you're given a number line. Sometimes you're just given a description and you could use a number line to solve them, but there's other ways as well. We're going to start with this problem number 2. When she woke in the morning, Josie noticed the temperature outside was negative 4.8 degrees Celsius. When she got home from school, the temperature rose to 15.6 degrees Celsius. What was the change in temperature? Well, we can find the change in temperature by just simply seeing the distance between the two numbers. So I could just find the difference between them. The change could be the difference. And I'm usually just going to take my larger number and subtract the smaller. So I'm going to take 15.6 degrees Celsius and subtract negative 4.8 degrees Celsius. And minus a negative is the same thing as adding a positive. And when I add these together, I get 20.4 degrees Celsius. That's the change in temperature. Number 4, if a dune buggy drives from an elevation of 10 meters below sea level to an elevation of 5 meters above sea level, what's the vertical distance that the dune buggy traveled? Well, it traveled the distance of 10 meters from 10 meters below sea level to get to the sea level. So I'm going to find the absolute value of that and add the 5 meters that it traveled additionally above sea level. So 10 plus 5 equals 15 meters. Number 5, what's the distance between the 2 points on this number line? We could do this a couple ways. We could look at it and say, okay, this distance from negative 4 to 0 right here is the absolute value of negative 4, which is just 4 units. And then we could look at this distance from 0 to 3, which is just positive 3, and we could add them. 4 plus 3 is 7. Another way we could do this is we could just count them and say 1, 2, 3, 4, 5, 6, 7, and it had a distance of 7 units. Number 8, Jake uses a number line to find the value of the expression negative 5 plus 7 plus negative 2. Part A, draw the last step on the number line. Okay, so we start at negative 5, and it went to the right 7 places, so it added 7. So we had negative 5 plus 7, and now we need to add negative 2. So we're going to go to the left because it's negative 2 places. And we've shown the last step. And so the value of the expression is where the arrows point to at the very end. So it comes out to 0. For this last standard, 7.NS.1c, and also the standard 7.NS.1d, but they're put together in your workbook, we're just going to add and subtract. So we're going to start here with problem number 3. What's the value of this expression? So I could approach this multiple different ways. I don't have to add them in the order that they're given. Commutative property says I can change the order when I'm adding terms, but I'm just going to go ahead and add them in the order they're given. So I'm going to start here with 3 plus negative 5.5. They're opposites. So when I add, I actually subtract and get 2.5 is the difference between them. And I take the negative sign because that's the number further from 0. Then I bring everything else down. We're just going to follow through with order of operations. Now I have negative 2.5 plus negative 8. These have the same signs, adding like signs. So we're going to add 2.5 plus 8 is 10.5 and keep the sign, a negative sign. And bring down the rest of the expression, plus 1/4. I could work with these as both fractions, or I could work with them as both decimals. Since 1/4 can be changed to a decimal, I'm going to go ahead and do that. So 1/4 is the same as 0.25. You can find that by dividing in your calculator. And now, last of all, I've got these two terms, negative 10.5 plus 0.25. They're different signs, so I'm actually going to subtract, which comes out to 10.25, and take the sign of the number further from 0, which was a negative sign. And so the value is negative 10.25. Number 6, if a minus b equals 7, what is also true? Well, glancing kind of through my answer choices, they're just rewriting the a minus b, and it should still equal 7. So notice that this minus b is subtracting a positive b. I can actually do the add the opposite, and that would be answer choice B. That's just following my rules of adding the opposite. Number 10, what's the value of this expression? Notice that we're subtracting with mixed numbers. So let's go ahead and start by writing them as both just fractions. It's not the only way to approach this, but that's how I would approach it. I could have looked to see if they changed to decimals, but this number here, 1/6, it will go to a repeating decimal, so we're going to have to work with fractions. So we're going to go around the world. I'm going to take 5 times 3, ignore the subtraction or negative symbol rather, and so we multiply those and we get 15. Then 3 plus, what we get 15, we add 2, so we've got 17/5, and then I'm going to keep my negative sign out in front of it. I've also got 6 times 1, which is 6, plus 1, which is 7, over 6, and keep that subtract symbol in front of that. Now when we add or subtract fractions, we need to have a common denominator. So we'll think of a number that 5 and 6 will both go into, a multiple of both of them, and that would be 30. So I have 17 over 5. 5 times 6 is 30, so 17 times 6 is 102. And then I have 6 times 5 is 30, so 7 times 5 is 35, and we have our negative in front of that. And now we're ready to just add or subtract. I could say this is a negative minus a positive, or I can say this is a negative plus a negative number. What it's going to come down to is they're going to be both treated like negative numbers. So I can add and keep my sign. So 102 plus 35 is 137. And it's an improper fraction, so let's go over and make this into a mixed number. 30 will go into 137 4 times. We get a remainder of 17, so it's 4 and 17/30. So that is equal to negative 4 and 17/30, which won't reduce any further, and we have finished this problem.